To determine the effect of different strength training methods on middle distance and long distance runners' athletic performance, Cristian and colleagues conducted a systematic review with meta-analysis. This is Talking Sports Science with a short summary of their article. First of all, regarding the study criteria, studies were only included in the review if they involved healthy, non-injured male or female amateur or competitive middle or long distance runners above the age of 16. The intervention had to involve some form of strength training, such as high-load training, submaximal load training, plyometric training, or a combination of these. Also, the strength training needed to be added to or partially replace the runner's endurance training, and had to last at least 3 weeks and include a minimum of 1 session per week. Studies using extra methods like electrical stimulation or supplements, for example creatine, were excluded. A proper control group was also required. This group either did endurance training only or did strength training with very low loads. Furthermore, outcomes such as VO2 max, velocity at VO2 max, maximal metabolic steady state, sprint capacity, or running performance need to be measured before and after the training intervention. And lastly, only randomized or non-randomized controlled trials were included. In the end, 38 studies met the criteria, involving 894 middle distance and long distance runners, aged between 17 and 40. 651 were male and 243 were female. 324 runners were considered moderately trained, 272 runners were considered well trained, and 298 runners were considered highly trained. Strength training programs lasted 6 to 40 weeks, with 1 to 4 sessions per week. In terms of the key findings, the analysis revealed plyometrics on its own didn't significantly improve running performance, while high-load strength training led to moderate improvements in time trial and time to exhaustion performance, whereas combining plyometrics with heavy load and or submaximal load produced large improvements in running performance compared to performing any single strength training method in isolation. These improvements occurred without changes in VO2 max, velocity at VO2 max, maximum metabolic steady state, and sprint capacity, suggesting adaptations leading to improved running performance are mainly due to non-metabolic factors such as improved running economy. Also, things like age, sex, training experience, VO2 max, or program duration and frequency didn't significantly affect the outcomes. Lastly, there are a few important things to consider. Submaximal load training alone had limited evidence, as only 2 studies used it in isolation, so it wasn't included in the main analysis for any of the performance parameters. For the 38 studies included in the analysis, the overall certainty of the evidence ranged from very low to moderate, mostly due to variability in training protocols and small study sample sizes. So while strength training, especially combined methods, is clearly beneficial for runners, the results should be interpreted with some caution. And that concludes this presentation. As always, for a deeper dive surrounding the literature cited in the review, it's recommended to go and check out the full article. The link is in the description. Thanks for watching, folks. See you next time.